3.5 years old when we moved into a new home outside of Guelph in the country where the skies were a little bit darker. And my daughter, Chelsea, was born there. She is the second baby. Chelsea was colicky and she screamed a lot, especially at night. But what would calm her down is I would put her in the colic hold over my arm, walk her up and down the driveway. She'd go to sleep and I was just getting more and more hooked on the stars. Meanwhile, when we moved to this new house in the country, we changed banks, got a new mortgage. And the old mortgage company, with whom we also had our credit card, said, well, you have all these Visa points. Why don't we, before we close out all your accounts, why don't we send you a catalog and you can get a few things. So I got something for the kitchen. I got a train set for my son, Todd. He was 3.5 at the time. And what I thought was a toy telescope. Anyway, it all came a couple of days later. The train was good. The kitchen thing was good. The toy telescope turned out to be a real 4.5-inch reflector. So I'm walking the baby up and down the driveway at night, getting hooked on the stars, and now a telescope arrives on my doorstep. Well, I looked at the moon. Jupiter and Saturn were prominent at that time. They blew me away. But the whole thing was rickety. The field of view was tiny. It was all really small. I made do with it for a few months. By now, Christmas was coming, and my good friend and business partner, Mark Goldberg, gave me a gift for Christmas of Terence Dickinson's book, Night Watch. Chapter 4 was called Choosing and Using a Telescope. And in that chapter, there was a sidebar article called Junk Scopes from Asia with a photograph of my telescope on it. So at that point, I realized that maybe it wasn't me that was struggling to get good views. It was the telescope. And I took my modest bonus money that year and bought myself a real telescope, an 8-inch Schmidt-Cassegrain, computerized, state-of-the-art Celestron Ultima 2000. And that was great. I was strictly a visual astronomer for a long time. But then I subscribed to Sky and Telescope magazine, and I really clearly remember one day getting my Sky and Telescope magazine and opening it to the back to the reader gallery where amateur photographs are published. And there was a photograph of M13, the globular cluster. I think I have a photo of it in my slide. There was a photograph of M13 that was shot by somebody using the same camera that I owned. And I remember taking it to my wife, Gail, and saying, this is unbelievable. I have to try doing this. And the rest is history. So that's a little bit about my astronomy history. Now let's get to the real history of astrophotography. And this speaks for itself. We're not just talking about photography. We have to talk about any effort that people have made to capture a likeness of the sky in any medium. So within that broad range of things is included these categories: cave art, which we talked about even a little bit before my talk began, buildings and landscapes, star charts, of course, sketches. I used to sketch all the time. I rarely do it anymore, but occasionally still do. Daguerreotypes, which preceded film photography, and then finally digital imaging. And I want to look at both amateur and professional imaging and how it's changed over the years. So we'll start with cave art and go back to the Lascaux cave in France. This cave art that you see on the left is 17,000 years old. There's a number of different astronomical references. The panel on the right comes from the Cambridge Star Atlas. And I'm not sure if you can see my mouse, but we can see Orion's belt and the bull. I'll highlight a couple of things for you. So the Pleiades are highlighted here above the back of the bull. And here's a photograph I've taken of this object. You can also see it in the Cambridge Star Atlas on the right. Here's Orion's belt, maybe an extra star. I'm not sure what that's all about, but it's approximately at the right location. And again, you can see it in the the Cambridge Star Atlas. This may be the summer triangle, the eyes of the bull, the bird, and the bird-headed man. Again, all part of the Lascaux caves. So 17,000 years ago, people were looking at the sky and capturing what they saw. Jumping ahead, and you know we're going to have to take big leaps as we cover 17,000 years in about 45 minutes or so. Now we get to the pyramids, which may mimic Orion's belt stars, with the Nile mimicking Eridanus the Nile as it was 4,000 years ago. So the Nile moves over time. My wife has done some really interesting work related to the Glastonbury Zodiac. So this is a location in the UK that was established around 2600 BC. It was first described in 1925 by Catherine Maltwood, and there's actually a Maltwood Museum at the University of Victoria. When I was in Victoria teaching PixInsight, Gail got to go there and was able to make copies and take photographs of all kinds of great material that she's using for her research. But at any rate, this large zodiac on the ground is delineated by roads, paths, streams, and earthworks that make all these effigies. Some people think that it may be related to Arthur's Round Table. And I've just highlighted one of these effigies for you, Leo the Lion. Gail's highlighted this with white lines so you can see it, but even if the lines weren't there, it's quite striking how it stands out. And all of the effigies stand out in this way. So again, if you want more information about this, you can look up Catherine Maltwood, information at the Maltwood Museum. As above, so below. So this was also that theme that we saw with the Egyptian pyramids, that were mirroring on the ground what people saw in the sky. So the most ancient Arab astronomers were more interested in individual stars than they were in the patterns of the stars. They did give stars some names, but really it wasn't until Ptolemy that we really got into constellations in a big way. Ptolemy identified 48 constellations in the 2nd century based on what he could see from his location. Now there are 88 constellations that cover the entire celestial sphere, and the constellations don't overlap. There was a period of time where some stars, you couldn't tell which constellation they were in, but the IAU now has these 88 constellations that do not overlap and that cover all of the sky. The first printed star charts that I saw, that I was able to find, were prepared by Albrecht Dürer in 1515. And you can see a number of the constellations here that we have today. So we've got Scorpius, the scorpion over here, Ophiuchus, the serpent bearer, Hercules along the top, Cygnus the swan. These are all familiar constellations. It's interesting, isn't it, that all the stars are shown to be about the same brightness. There's a couple of brighter stars, for example, shown here in Aquila. We don't see Deneb in this cutaway, so I don't know if it would be marked as brighter. In 1551, we have the Mercator Celestial Atlas, and there's a lot of historical atlases available at this link. This is where I found some of these lovely graphics. This shows Orion, and you can see Orion's belt and his sword. He's holding, looks like a bone club and a shield. In 1608, Hen Lippershey patented the refractor, and that really changed everything. So that was a major technological change that made a different kind of astrophotography possible. In particular, now we could start sketching with some detail. This is Hevelius's moon map in 1645. You can see the main features that we see now. The Maria, the gray areas, and the craters that show shadows, and rays that show the material that's splashed out of the craters called ejecta. Star charts from 1690. Again, this is a Hevelius star chart showing familiar constellations and now very clearly delineating stars of different brightness based on their size and their shape, whether they're filled, whether they're hollow. So now we're jumping ahead a couple of centuries to the 18th century. This is a northern sky star chart that shows 4 important observatories of that period of time. So in the upper left, we have Tycho Brahe's observatory in Denmark. The Paris Observatory is shown at the upper right. Lower right, we have the Nuremberg Observatory in Germany, and Hevelius's private observatory in Poland is up at the lower left. And now we've got really quite ornate, three-dimensional looking drawings to go with the stars. And hard to see in this particular, the way this is displayed small, but you can see stars are shown with different brightnesses called magnitudes now. And at the very bottom center, you can see the brightness scale shown for the various stars here. 1843, things evolved a little further with the first Uranometria nova. And again, we're seeing much more detail. Now we're starting to see quite clear delineation of the brightest stars, like the one just below center here, and then below it, slightly fainter. And of course, now we have Sky Atlas 2000 and many other atlases. This again is from the Cambridge Star Atlas, a very busy region in Cassiopeia that lots of us amateurs like to shoot, full of star clusters and beautiful nebulas. And so now we're showing double stars. So these, if you look for the just the right-hand dip of the W, near the bottom left of it, you'll see a star that has a line through it. That denotes a double star. And now if you look around the image, you'll see there's quite a lot of double stars. The length of the line tells you how far the double is. The very center star of the W has a ring around it. That denotes a variable star that changes brightness. And the size of the outer ring and the inner ring tells you how much the brightness changes. So our drawings and maps are getting more and more sophisticated to the point that now I can get all this on my phone. So let's move on now to sketches. So this is really now people were starting to sketch what they see. This is a part of Orion's belt that was sketched by Galileo. And again, you can see the very brightest stars of the belt. And there's a lower one here. I think that's because he was using a refractor straight through that would have inverted the image, because now that fourth star is, I think, above the belt. So sketching continues to be done today. One of the advantages it has as a type of astrophotography is that it's very inexpensive, and some people actually find it enjoyable. Some people don't find it enjoyable. It can be very stressful. I remember one time I sketched a comet. I'm not sure if it's here, but I had been waiting all day to sketch this comet going past a star cluster, M44, the Beehive. And it clouded over. And I just waited and waited, and I was lucky enough to get a clear patch. But what I had my binoculars in my left hand, my flashlight in my mouth, my pencil in my right hand, and the sketch pad on my lap. And I had to get the whole thing in about 5 minutes before it clouded over. So, you know, some people find that fun, others not so much. But sketches are really important in terms of the history of capturing the sky. And you can see just in the span of 66 years between the upper left sketch by Galileo and Cassini's sketch in 1676, how much more detail was able to be captured through telescopes by people with sharp eyes, patient people with sharp eyes. So by 1676, you can really clearly see that Cassini was seeing a ring, and furthermore, he was seeing what we now call the Cassini division, the dark line in the ring, that is just striking that we can see that here as amateurs from Earth. This is perhaps hard to see on the screen, but here's a couple of sketches that I made of the planets. Jupiter in 2009. Jupiter is actually the easiest planet to sketch. And if you're interested in doing this, make the template before you go outside. Jupiter is squished at the poles, so it's kind of oval, not round. Make the template inside. You can get templates from the Association of Lunar and Planetary Observers website. And you can fill in a lot of the shading and where the main bands are before you go outside. And then when you go outside, use your pencil to mark in the fine details. On the right is a sketch that I did of Mars through my 20-inch reflector on the night of close approach in 2003. And no, Mars is not going to be as big as the full moon again this August or ever. So a couple of technologies developed in parallel to make imaging with light possible. First one was telescope optics and mounts, and we talked a little bit about the refractor. The second is ways to actually permanently capture light. The first astronomical images made with light were daguerreotypes around 1840. That was silver-plated copper that was coated with silver iodide, and it was developed using mercury vapor. I'm a toxicologist, so this is just a toxic mess. I would not want to be involved in that type of astrophotography. A camera obscura was used for the exposure, all manual. I'm going to show you a picture of how this was done shortly, although I can't say I completely understand the picture of how it's done. There you go. The camera obscura part is here in center right. All of the other stuff is required to develop and clean the daguerreotype plates. This is another look at the camera obscura. Another important change in technology happened in 1839 when John Herschel developed glass plates. And in fact, they became the de facto standard for photography for the next 150 years. The first moon photo in 1840 on a glass plate required 20 minutes of exposure. now we want 5/10,000ths of a second to get a good exposure of the moon. There was a shift to film emulsion, which increased the sensitivity of the film. And then astronomers started using gas hypering. So they would put their film in the freezer with ammonia gas and hyper it. And what that did is it helped the film avoid a problem that film has called reciprocity failure. And what that means is that when you double the amount of light, you don't double the amount of signal that you see on the film. That's not really a problem with digital cameras, but with film, it was a big problem, and gas hypering and cooling helped. Now, cooling could be a problem too. I do remember photographing an eclipse one time in the middle of winter. It was -25, and I was using film. And when it was all done, I went to rewind my film, and it went click, and the film broke. It was so cold, and I never was able to get anything from that eclipse. Anybody remember the brownie? All you old guys like me out there, I had one of these at camp. And one of these, the Instamatic. Remember the Polaroid land camera? So this was one of the first cameras that could take a picture that would develop magically before your eyes. And these could be used for photographs of the moon. I saw a few of those. And I actually used a Polaroid camera to take a photograph of Mars through the eyepiece one time. So yes, you could do astrophotography with a Polaroid camera. My mother had a Pentax 101 that she used to love. And my first photos were taken with, I believe it was, sorry, her camera was a Minolta 101. And I think my first pictures were taken with a Pentax similar to this. But of course, most of us now use CCD or CMOS sensor. CCD is a charge-coupled device. And CMOS stands for complementary metal oxide semiconductor. You might know these as chips or sensors. And they've really revolutionized both professional and amateur imaging. So my first photographs of the aurora, I used a camera like this. So this is actually a digital Olympus camera, and it would shoot JPEG. At that time, I didn't know about RAW files that allow you to do more editing. And I just captured JPEGs of the, we had some really nice auroras back in 2003 and 2004. And I used a camera like this to capture those. This was one of my first serious astrophotography cameras. The sensor is behind where that black nose piece is. And the reason why it's this shape is that inside it, there's a wheel that has 5 filters in it. So the sensor is black and white, and you move different filters into place to capture different colors, red, green, blue. Some people use a clear filter. Some people will use filters that just let through very specific wavelengths. So they're trying to capture the emissions of elements like hydrogen or oxygen or sulfur. This is a webcam, a really old webcam, but it turned out that these could be used for planetary photography because you could take a lot of photographs in a short time, and some of them would be good. So that was kind of the basis of lucky imaging. And also you could use these as guiders. So here's another webcam. I had a webcam like this that I turned into my first auto guider. Malincam. About 10 years ago, I think, these really made a splash on the scene. And this is a video camera that would go where your eyepiece goes in a visual telescope. and you connect it to a little screen. It's great for outreach. It allows everybody to see what the telescope is seeing. Not particularly expensive, not too hard to use, and it's great for real-time astrophotography. I have a camera similar to this. Mine is a 70D that I had modified. But Canon and Nikon, for about the last maybe 15 years or so, Nikon after Canon, Canon was first, they've been making regular DSLRs that they then modify and optimize for astrophotography. And some people are taking fantastic photographs with cameras like this. If you get a chance, check out Carrie Leckie Hepburn's Earth and Sky, Weather and Sky page, Astrophotography. She does these amazing shots of the Milky Way with the DSLR with fantastic landscapes like Easter Island or Death Valley in the background. Really, really wonderful what you can do with a consumer digital camera. This is my setup in my observatory. I have two telescopes. The one on top is a Takahashi 4-inch, and it's got a one-shot color camera on the back of it. So that's the black cylinder with the red stripe. It's kind of like a DSLR in that it acquires all the colors at once. The one on the bottom, the square-looking camera on the larger telescope, that's a 6-inch Skywatcher refractor. So the camera on the back of it is a black and white camera, and inside the big black square is actually a filter wheel that has 7 filters in it. And it has the 7 I mentioned before. So red, green, blue, clear, hydrogen, oxygen, and sulfur. And tonight, after the presentation tonight, I plan to be imaging in hydrogen alpha all night to capture the beautiful nebula knots of spiral galaxy Messier 101. So there's just a couple of close-ups of those two QHY cameras. There's actually a third camera in this picture, which is the little silver camera stuck into the black camera on the bottom. That's a guide camera, so that tracks just one star. And if that star moves off the crosshairs, a signal is sent to the mount to correct its position. And that helps to keep my stars nice and round in my photographs. This is the Wide Field Planetary Camera 3 from the Hubble. Big step up from what I'm using, but operating by the same sort of principle and connected to a telescope that, in terms of its size at least, is quite modest in its size. So let's see what you can do with all this equipment and how things have changed over the years. And in the next few slides, I'm going to give some older photos and then some newer photos, including some of my own. So we have, these are all photographs of the sun and the moon. So we've got a daguerreotype of the sun at the upper left, a solar eclipse from 1851 in the center, and a daguerreotype of the moon from the Harvard Observatory in 1852. This is my photo of the Venus transit. So this is 60 odd years later. We're able to do so much more. Looking at some images from the 19th and 20th century, these are from professional observatories and cameras. So at the upper left, we have the Orion Nebula M42 in an almost 1 meter reflector. This is from the late 19th century. A 60-inch reflector in 1919, the Eagle Nebula. You can see the famous pillars of creation in the center there. And at the bottom right is the Fireworks Galaxy. This is a pretty famous galaxy because it's had a lot of supernovas in it. So 1933 is the most recent of these 3 images. And here's my images of the same regions all 60, 70, 80 years later. So again, this is amateur equipment from a relatively light polluted backyard in Guelph, Ontario. Messier 13, a beautiful globular cluster, one of my favorites. The double cluster from 1910. And a 1970 image from the Lick Observatory. So 1970, that's 50 years ago now, if you can believe that. Here's the same three objects shot from my backyard, again with amateur equipment. One kind of interesting thing is that you can see how objects change over time. So this is an image of the Crab Nebula. The Crab Nebula contains the first pulsar that was confirmed. And this image was from 1942 from the Astrophysics Journal. I imaged it in 2014. And if you go back and forth, you can actually see that the supernova remnant has expanded. So if you look at these two bright stars on the top edge of the supernova, they're clearly within the supernova in my image and clearly outside it in the older image. And other features you can see have moved relative to stars. So if you look on the left side, about a third of the way in from the left side of the supernova remnant, you'll see there's kind of a dark triangle with a bright star in it. Just above it, there's this triangular wisp, triangular tendril. You can see that in my image, that tendril has moved closer to the star. All right. Sketching again. So this is on the left is a sketch by Lord Rosse from 1845. He was the first person that described spiral structure in a galaxy. And this was his sketch. I took a photo of this object in 2013. And, you know, arguably his photograph in some areas shows more detail than my photo does. So even at that time, a well-trained, careful eye could get amazing detail. Yes, I may have some more detail in the core and so on, but this sketch got the direction of rotation. It got the bright and the dark gaps. It got these kind of star clusters that are blue in my image. There's Hubble on the left compared to mine. I guess I still have some work to do. But you do have to think about the value proposition in this business. So my most recent repair cost $730. I broke the camera that you see on this telescope. It's the gray camera down here. And I had to send it in for repairs. Took 2 weeks, $730, and I was back in business. Hubble cost $1 billion to repair. So, you know, my cost per image is less, so there, Hubble. Take that. Just share a couple of recent images with you. This is the Veil Nebula, another beautiful supernova remnant. And this is an example where the light can tell you so much about the chemistry of the object that you see. The red emissions that you see here come from excited hydrogen atoms that are releasing their excess energy as red light that gets through my hydrogen alpha filter. And the beautiful teal color that you see, excited atoms of oxygen that are releasing light. And they release light at both blue and green wavelengths. So together they appear to have a teal color. And this, you know, we're just lucky to be here at this place in space and time to be able to witness an object like this, because it's expanding. And as it expands, it becomes more and more tenuous. and it will dim eventually until it can't be seen anymore. So we're just privileged to be here to see this object. This is a very recent image of a globular cluster. You know, all of the stars that you see outside the cluster are just Milky Way field stars, but there's probably 300, 400,000 stars within this one particular globular cluster, just one of about 150 of these balls of stars that orbits around the Milky Way galaxy. And it looks like most spiral galaxies have them. And this is another beautiful galaxy, Centaurus A, not visible for me. Sometimes I beg data from my friends in the southern hemisphere, and I share my northern hemisphere targets with them. So this is Centaurus A. This is another recent object. I just did this spring, the Running Man Nebula, just above the Orion Nebula. I don't know if you can see the Sasquatch character in it running from right towards the left-hand side. You can see his, I hope you can see my mouse. You can see his arms extended in front and behind him. Here's his kind of squat head and body and one leg and then the other. So there's a lot of stuff that I could have talked about, but didn't, because we only have, 45 minutes or so for this presentation. And the most important is that there are so many different cultures that have contributed to capturing images of the cosmos that I didn't even touch on. I didn't really talk about any of the South American, for example, and Central American cultures that contributed to capturing images of their skies to the world. We didn't talk at all about the practicalities of imaging. How do you catch those photons on a sensor and turn them from electrons, photons to electrons, and electrons to pictures that you can share with your friends? And of course, everything I showed you was images in the visible spectrum. But of course, now we recognize that the visible spectrum is just a small portion of the electromagnetic spectrum that includes gamma rays, X-rays, ultraviolet, infrared, radio waves, microwaves, and so on. And imaging in all of those different wavelengths has the ability to contribute to knowledge and understanding of everything in the universe. If you want to see more of my images, please go to astrodoc.ca. Proudly Canadian, that's why it's not a .com, it's a .ca. And my email address is there. Please go ahead and write me. I love to hear from people. rbrecher@rogers.com. By the way, Karim, you introduced me as Ron Brecher. I've been called worse. No problem.
I realized that the minute I said it.
It's okay. It's okay. It happens all the time. Some people just tell me I spell my name wrong. There's lots of other resources on the internet. I found these particularly interesting. So astrosurf.com, History Astrophotography, has some really cool stuff on the history of astrophotography. Karim has a copy of this slide deck that he'll make available by request to anybody who asks as a PDF, so you don't have to jot all these down. My wife has some stuff at secretsofthegraillandscape.com. That's always a work in progress, but you can find some of the Catherine Maltwood effigies and some interesting Google Maps and so on. If you want to learn more about the Lascaux Caves, I've given you a link for that. And the Hubble Heritage Gallery is the fourth link for some just fantastic photos taken from space by the Hubble. And with that, I'll say thank you very much for attending. Nice to see some familiar faces, or at least the names of familiar faces, and happy to take your questions.
Thank you so much, Ron. And I've put an email address in the chat so that people can drop me a line. I can pass them the slide printout of today's presentation. And does anybody have any questions they'd like to ask to Ron?
It might sound a little bizarre, but like, how do you get started in this for somebody who's new to the field? How do you go about just saying, okay, I'm going to take a picture of the sky and then hope for something to come from that?
Well, for a start, use what you've got.
Okay.
So the first thing to do is put a camera on a tripod and try taking a photograph of the moon. It's up 2 weeks out of every month, so you're bound to get a clear sky. It's really, really interesting, and it doesn't matter how little or how much you zoom in on it. So you can practice really essential skills like framing a target, getting things in focus, and getting the exposure time right to expose the dim areas adequately without overexposing the bright areas. But astrophotography, you know, it's a bit like eating an elephant. You got to do it one bite at a time. So start with something easy with the equipment that you have, like the moon. If you want to go a little beyond that, then you're going to start shooting things like star fields. So with short lenses, say 14 or an 18 millimeter lens, you can just point it at the Milky Way and take a 5-second exposure, and you might get a nice result. You might need to do a little bit of processing in PixInsight or Photoshop. Most of you would know Photoshop to make the colors look good. But start with the moon, move on to short focal length Milky Way. If you want to go beyond that, there's all kinds of resources on the web for how to get started.
Thank you, Ron.
But you know what? As much as we've talked about photography, Kareem, you and I talked about this over coffee. There is no substitute, there's no camera that replicates the experience of having that photon hit your retina coming through the eyepiece.
Exactly. Your
Photography
perspective.
is great, but it sure does not replace the visual experience. Now, you know, for some people, the visual experience is not possible, either due to disability. Some people are not comfortable going up a ladder at night or even being outside at night. Some people don't like the cold. And a lot of people have to sleep at night. Astrophotography, I know it's funny, but astrophotography provides a way for us to share the sky with those people.
It's true.
But there's no substitute for those photons slamming into your retina.
Chris's daughter has a question.
Great.
So like, did different cultures have like different ways of expressing the constellations, and how come we use like that culture's ideas of the constellations up to this date?
So there are different interpretations of the sky from different cultures, and the main reason for that is that different cultures kind of sprung up and flourished in different places and at different times. So first of all, they didn't all see the same parts of the sky. And second of all, when they did see the sky, they saw different patterns. So people are pattern finders. We're very good at seeing patterns in things. And the patterns that people would find would be based on the way they were brought up, the kinds of objects that they see and think about in their own societies, the kinds of animals and plants that might exist in their societies. So that's why different cultures would see the sky in different ways and ascribe different patterns. Now, the system that we have right now was established, as I said, by the International Astronomical Union, and it's 88 constellations, and it's all very scientific. not cultural, except for the fact that it's based in the Greek assignments of the constellations.
Can I cut in here?
Yeah, thanks.
Go ahead, Robin.
It's interesting what Ron is saying about patterns, because he's absolutely right. People did see patterns, in the stars and the constellations. They also saw patterns in the sun's corona during total solar eclipses. And I'm going to show you a pattern right now. I hope you can see it. This is a photograph of the 1991 total solar eclipse. It may not be working that well, but do you see a pattern here?
The shading on the left side?
The overall pattern.
Yeah.
Do you see a bird? It may not, like, the camera may not be showing it that well, but there is a bird-like pattern in this photograph of the sun's corona, I can assure you.
It's kind of like the Running Man. When you see it, you see it. And until then, you're not quite sure what you're seeing.
Right. Yeah, well, the technology here is not the greatest. I'm holding up a magazine, but you can see the wings. You can obviously see the wings on either side of the sun. And then if you look up above and below, you'll see this fan-like pattern. Anyway, that bird, I first saw that pattern in, when I saw that magazine back in 1992. It arrived on my doorstep, and I saw the bird. And when I saw that bird, I immediately thought, this is most probably the origin of the Phoenix myth. And I did the research, which supported that idea, and I found a whole flock of mythical birds all around the world. So anyway, I don't want to hijack the conversation here, but
that's excellent.
Patterns, like Ron saw the Sasquatch in this, nebula. We can't see that with the naked eye, so we can't imagine a Sasquatch is something that we can't see with the naked eye. But people saw these things with the naked eye.
Yeah.
They saw the bird, and that had a huge effect. And you're Middle Eastern, I believe, Iranian background. I'm sure you've seen the pharaoh heart symbol of Zoroastrianism.
Yes.
Yes. Well, guess where that came from?
Can you guys see, are you able to see the image on my screen, the North America Nebula?
Yes.
So I have to show you something here that after I show it to you, you're never going to be able to unsee it.
Okay.
Okay. So I know we have some non-astronomers here. So for you guys, I want to tell you, first of all, the famous part of this. And this is the North America Nebula at upper left. So you can see it kind of looks like North America with the Gulf of Mexico. And here's Central America going downwards. And then over here to the right-hand side is what's called the Pelican Nebula. And I don't know if I don't think I can make that bigger easily, but I'm going to try.
I see Great Britain and Ireland.
You can go
yeah, people see all kinds of things. But after I show you this, you're never going to be able to unsee it. And I do have to go into the picture format thing so that I can try to zoom in on this. All right.
You can also go to view and increase the size of that.
That's okay.
Okay.
Once I get in here, it's all gonna be fine. So my wife pointed this out to me, and now I can't unsee this. So, do you see the lizard head? Do you see the lizard head looking out of the cave?
Yeah.
Yeah.
Yep.
I can't unsee that now. So he's got one bright blue eye and one orange eye, and he's looking out of this cave.
Yep.
And so here it is, the whole thing again. You just can't unsee that.
Well, it's funny you mention a cave specifically, because the total eclipse sun, coming back to that, you have this round circle,
Mm-hmm.
the black moon. Well, that can be seen as a hole in the sky, obviously.
Sure.
and it's been referred to as that. And I've been researching how eclipses were interpreted, responded to by ancient cultures, and I do believe that some of them saw that hole in the sky as a cave, or associated it with caves. And don't forget, bats come out of caves. So another weird creature that you see at night. And don't forget that eclipses turn day into night. So some cultures saw the winged creature in the corona as a bat. And so it's easier to make the connection to caves there.
So Ron, Bettina was asking how much processing you do in Photoshop.
I don't have Photoshop, don't own it.
Do you use GIMP, or what do you use?
I use PixInsight.
Okay, directly.
Period.
There was also a question asking if professional astronomers use the photographs taken by amateurs.
Absolutely. In fact, I'm kind of excited to tell you about a discovery that you might read about this, the 30-degree arc that was found in the region of the Big Dipper. It's a 30-degree arc that looks like a shockwave from a supernova, and it's the largest such structure now. It's bigger than any other supernova remnant discovered. So originally it was thought of, it was like a 2-degree arc. Now they've extended it 30 degrees, and my friend Sean Walker, he's my editor at Sky and Telescope. I don't know if you're on the call, Sean, but if you are, hello. He's part of an amateur survey group, the MDW survey group. Pardon me? Oh, sorry. Anyway, he's part of this survey group, and they have surveyed this part of the sky in H alpha and got the confirming photographs that confirm that arc.
So it's a 30-degree arc.
Yeah, it was. I think it was just announced formally by the IAU at their weekly briefing a day or two ago.
It was also an amateur astronomer who first identified the 2020 supernova that people are imaging right now. Gerald and Dominique Gerald and Dominique from our club just got the image last month of it.
Fantastic.
David Schumann has a question for you. I'll turn it over to him. I'll let him ask it himself. From the ISS.
Hi, I'm with Bob and Doug up here. They just recently joined us. Great talk, by the way. Thank you so kindly. What do you think is around the corner for amateur astronomy, like more sensitivity, more resolution, or something completely different? What do you think's the next thing that's going to come out?
I think CMOS cameras are overtaking CCDs. CCDs really aren't being manufactured anymore. CMOS cameras are going to take over. They're cheaper to manufacture. So I think the price is going to come down on equipment. That means it's going to be more accessible for more people. But I think what we're seeing now is a lot of computerization of telescopes that makes it easier for people to find things, so that they're spending more time looking at things and less time trying to find them. My thinking on that has changed over the years. I started by learning the sky, and I really encourage people to learn the sky. There's no better way to appreciate what you're looking at than to really get to know your way around the way you know your way around your neighborhood, you know. But the computerization of these visual scopes that allow you to put your cell phone on the telescope and use that as a pointing tool, that's just going to make everything more accessible for more people. Now, I think, unfortunately, one of the things that's ahead for amateur astronomy is a continuing degradation of the night sky. And all of us have a responsibility to do what we can locally, say what we can to our friends, raise awareness of that to try and preserve the sky as much as we can. From an astrophotography point of view, I'm personally not that worried about the Starlink satellites. We can sigma clip them out in processing you know. But there's so many cool things to look at if only the sky were a little bit darker at night.
Well, they just put the umbrellas to the latest batch that went up yesterday.
Yeah, that's great.
So we'll see if that dims these satellites down. But there's 40,000 more to go up. So.
Yeah. But, you know, planet season is coming. Jupiter and Saturn are going to be really well placed for observing in the next few months. And if you're an amateur and you don't want to get hooked on, if you're just thinking about starting out and you don't want to get hooked on astronomy, don't look at Saturn. Yeah. Once you see Saturn, it's all over but the crying.
It's actually, we do a public event at Summit Circle in Westmount every September, and David knows that event very well. And last year, 2 years ago, last year was rained out, but 2 years ago, we had a telescope on Saturn, and this one woman came while my son was running it, and she saw the rings, and she was just tears in her eyes, hugging him and sobbing into his shoulder, saying that she'd always read about it and heard about it, but to see it was just, she could not compose herself. Those moments, they just... So there's a question here from John. He was asking about tracking methods for fixed objects and then tracking for orbiting satellites, which is actually incredibly difficult. I know a few people who've gone out as amateurs trying to catch images of the ISS as it passes and have found it incredibly difficult. Do you have any suggestions for that?
Yeah, keep trying. It is incredibly difficult. You know, the most successful photographers take a lot of pictures and delete a lot of them. That having said, and you know, you can't buy your way into this hobby, but a good mount helps. Some mounts are capable of tracking the space station or other satellites and imaging it because they can slew. In other words, that word slew, if you don't know the word, S-L-E-W, is what a telescope does when it moves across the sky quickly, as opposed to tracking, which is what it's doing when it's moving slowly to keep pace with the rotation of the Earth. So when you want to track the space station, it's moving very quickly against the background stars, and you need a mount that can move that fast. And not all mounts can do it. Yeah. So, you know, there are technological requirements, there's equipment requirements to get a good result there.
One of the nicest images that came out last week was an individual tracking the ISS who was able to see the Dragon capsule following around behind it. That was from Nova Scotia that they posted that one.
I was watching that night. I saw that pass. I didn't see the Dragon.
We got all clouds here.
And also the prediction that I looked at had the Dragon capsule ahead of the space station, which of course it wasn't. It was following the space station, and I did stay out, but I wasn't lucky enough to see the Dragon.
Well, its magnitude was, I think, like 5.8 or something like that. It was going to be very difficult to catch by naked eye, and by instruments, it was going to require multiple imaging.
Mm-hmm.
It's the same as Comet Swan right now in the mornings, and that's competing with sunrise, so nobody's catching too much of it right now.
Yeah, and you know, it was just right around, maybe a little after civil twilight when it passed. So we hadn't reached astronomical twilight at that time. So my limiting magnitude probably wouldn't have been, I wouldn't have been able to see the Dragon.
So David Kolb mentioned that the Starlink were a big talking point at the AAS conference this week. And there was a question later on asking how much Starlink and different satellite constellations that are being proposed are going to affect the quality of the observations. And I know locally we've had kind of a discussion on the algorithms that are being used to try to subtract the satellite constellations out of images and how much that affects your actual image quality when you start subtracting pixels here and there. Any thoughts, anything you wanted to mention for that?
Yeah, absolutely. So I'm going to give this from two perspectives. So the first thing I want to clarify is that what I do is art. It's not science. It's true that my raw data could be used for scientific purposes, but what I'm using it for is to make pretty pictures. And for making pretty pictures, it's not going to affect me at all. It's no different than having an airplane go through one of my frames. I don't throw that frame away. I use large scale pixel rejection to identify those aberrant pixels that aren't in any other of my pictures and make them go away. And I'm not actually subtracting pixels. What I'm doing is I'm replacing a pixel value that isn't valid with a pixel value that is valid. Now, dangerous medicine, you can use that for evil too, right? You can use that to insert structures that aren't there or erase structures that are there. And I've seen people do that. There was a famous, infamous astronomy picture of the day published by NASA maybe a year or two ago. Robin, you're nodding your head. I'm talking about the Saturn photo, right? That had the ISS clone stamped all through Saturn, transiting Saturn. And it was the same photograph of the space station pasted in multiple times. So, you know, you can process for evil too. But with the space station or Starlink or anything going through my images, it'll just be subtracted. From the scientific side, ground-based telescopes are going to have to use algorithms to separate Starlink. But having said that, their fields of view are tiny. In general, very small fields of view, and most photographs will not have a Starlink satellite pass through them. Furthermore, although we're talking about the number of Starlink satellites that are going up now, there are already thousands of reflective objects up in space now, and we're managing just so fine. So am I happy about Starlink brightening up my sky? No, but I'm really not too worked up about it either. I'll manage.
I think it's also a scale of magnitude, because we have thousands up there, but having tens of thousands and not having them in an orbit where we don't have to worry about them, because they have to be in a relative orbit where we can interact with them in order for them to be effective communication satellites, is part of the issue.
Yeah, but from what I can tell, they're not going to pass through most of what I image, which is 30 degrees above the horizon.
True.
Plus, I'm shooting in astronomical darkness. So when they're high up in my sky, I've got the Earth between me and the sun.
So David was
I've got the Earth between the satellite, the Starlink satellite, and the sun. So
David was mentioning that in the AAS, I guess in the AAS discussions, they were also talking about the impact on migratory birds.
Oh, yes.
Yeah.
Particularly things like the indigo bunting, which navigates by the stars.
Yep. So these are all larger issues. Anybody have any questions in terms of the talk or in terms of astrophotography or equipment? I know a few of our members were itching to chat about processing and different equipment preferences, but I don't know if that's what we want to talk about now, or if we want to talk a little bit more about sketching, which I loved your sketches, by the way. The sketch of Mars and the sketch of Jupiter is, we've been doing some emphasis on lunar sketching lately at the center, and the new Explore the Universe certificate that's going to be starting the programming from RASC National starting end of this month. They're going to be suggesting to be able to sketch when you see a Messier object and when you see a planet, and to try to capture the details better. And that's one of the things that they're going to be really trying to show examples of. So it was nice to see that tonight.
Yeah, one thing I'll say about sketching, for me, one of the things that sketching did was change me from a looker to a seer. I would say that when I started as a visual observer, I would go out with a star map or a checklist or something, and I would just move my telescope from object to object, maybe spend a minute or two there, got it, check, check, check. When I started sketching, it changed me from looking and checking boxes to wanting to spend 20 minutes, 30 minutes, an hour, 2 hours with an object, really, really seeing it. So maybe it isn't round, maybe it's a little oblong. Is it brighter over here or brighter over there? Can I see this little faint thing that I think I see? What happens if I put a nebula filter in the way? And sketching changed me from a looker to a seer. So now when I go out, I pick a few objects and I just hang out with them for a while and really experience, you know, let my eye get saturated.
So we've been kind of lucky at the Montreal Center because with Bettina leading the loonies a while back with crater sketching, and our member liaison right now, Nicole, she actually goes out with black index cards and white pencils in order to sketch
Great.
what she's seeing. David, when he shares his journals of observing, you see the sketches of everything he's seen throughout his entire career as an observer. And then we get to see such wonderful astrophotography and captures of images, and so it's been fantastic. And so along those lines, there was a question for you, Ron. If you could show the photograph that you're most proud of and tell us a bit of the story behind that photograph.
Sure, but you know, before I do that, you were talking about logs. Here's my log. I don't know how well you can see it, but I kept a multi-volume pencil log, and
Oh, wow.
these are like these are Polaroid photographs of Jupiter.
Did you
and
do
the
that
great
through,
reds.
yeah, through the eyepiece with?
Through the eyepiece, yeah.
Yeah.
And you can see it's all written in pencil. And I've got 3 volumes of this. This is when I was learning, so I was gonna try and look at M97 and M108 that night. So I drew myself a little sketch of the Big Dipper, of where they were, and I wrote down what my impressions were and all that stuff. So it's great having these memories.
That's fantastic.
It might help if he was full screen showing that.
Yeah, do you
For
want
me?
to, let's put you, let me see if I can put you to full screen.
Sure.
There we go. Can you show that again?
Yeah, let me just, I got to get back to the page that I was on with the Polaroids.
One of the exercises I've actually started with the students is that they have to do 4 sketches of the moon identifying different features. They could take pictures, but at least one of them has to be a sketch. And so they all find that they have to find a way to draw by hand what they're seeing with eye of the shadows and the craters and everything. And this last semester, there were 2 students who decided to try to get away with doing the new moon, and that didn't go.
That was my first shot of Saturn.
That's
and
gorgeous.
when was that? November 16th, 2001. And that was with a point and shoot camera held up to the eyepiece.
Nice.
That's your 11-inch, or what size?
That was with, let's see, that was an 11-inch Schmidt-Cassegrain telescope, seeing 3 out of 5, transparency 8 out of 10, 2 degrees C, no wind.
What type of eyepiece was that? Because that's a lot of good resolution on
8 millimeter radian. What else do you want to know?
That explains a lot.
So now, you know, I don't keep, I can't say I keep a written log anymore, but I have my photographs or my log, and they're all time stamped and everything too. So.
I have a photo of the ISS that I took that I want to share because you know, usually you get this little kind of grain of rice thing, you know, and I shoot with my iPhone, and I blew it up in iPhoto edit, you know, on my phone, and I don't know if you could see it, but I got
fantastic.
That's amazing. Yeah.
Yeah, and that was just handheld with my iPhone 7.
Held to the eyepiece or held to what?
No, Ron. This was not through a telescope.
You pointed it at the sky.
That's the original.
Oh my gosh.
And then I blew it up, you know, in the iPhoto edit process, and this was what I was able to extract from it. And that's legit, right? I mean, that's the ISS, isn't it? Because I don't know. I mean, I
don't know. Is it, David?
I think it is, actually.
You know, and, you know, honestly, that's what I got. Handheld iPhone 7. I think I should be on a billboard that says this was taken with the iPhone 7.
And that was taken with the native lens, no zoom lens, nothing.
Nothing.
From the dot in the sky. Wow. I'll tell you, when I photographed the ISS passing in front of the moon, I realized it has to be 1/3000th of a second to freeze the image. So the image of the ISS I have in a video, you could see the panels and the modules, but they're blurred slightly.
Yeah.
So that's incredible.
Yeah. So it's possible to be a amateur astrophotographer with an iPhone and a telescope, because everything I shoot is just what I get held up to the eyepiece of my modest Celestron SLT Nexstar 130.
Yeah.
Hey guys, do you mind if I share? Do you mind if I share a picture I took last night when in Montreal it was cloudy?
Go right ahead. And while you do, if Ron can find the photograph that he's most proud of for the story, for the question that somebody asked.
Sure.
You guys see that?
Oh, wow.
That was last night at 10:30 at night. And Ron, just like you said, it took me about 100 photos, 8 seconds a pop, and a lot of patience. But this time I didn't have to throw my negatives away. It's, you know, it's my Sony Alpha 6300, 8 seconds, ISO 100. And I just kept clicking and clicking and hoping to get lucky. And I got 3 sets of lightning. This is just one shot of 8 seconds, and from my my friend's balcony last night.
Nice.
So a few moments before you got this, did you hear somebody shout Shazam?
No. Just wanted to share that because even if it's cloudy, I got to take stuff in the sky. You know?
Absolutely.
Okay,
I find it cool to see it. Like normally with the lightning, you see like a dark gray sky. It's cool to see how it's light blue.
Yeah, that was the natural color balance. Once in a while, if you look at lightning storms on the horizon, you'll see a little green flash. Those are usually transformers getting struck by lightning. And I see that often. You could see like a bright green glow when the lightning hits something on the ground. But like I said, whether it's nebulas or the local Montreal nebula, they've got to do something with the night sky.
I have that photo.
Excellent.
If you want to see it.
Please.
Should I
We'd
go
love to
ahead
hear the
and
story. Yep.
Okay, so I don't know how much of a story it is, but
that's why it's your favorite.
Yeah, well, you said the one I'm most proud of.
The one you're most proud of, yes, sorry.
So this is the photo that I'm most proud of. Can you guys see it?
Yep.
Okay, so what this is Sharpless 129, the Flying Bat Nebula, which is the red object. And inside it, you see kind of a ghostly green, squiddly diddly looking thing, which is called the Squid Nebula, OU4. And this is the image that I'm most proud of. And there's a few reasons why I'm proud of it, but I guess the main one is that this was on the cover of the Handbook of the Royal Astronomical Society of Canada.
Yep.
On the 2019 edition. And you know, I've been a member of the society, I think, for about maybe 20 years, maybe a little bit longer. And I always admired that cover. I never, ever imagined I would be on the cover. And when the editor called me and offered it to me, that was a huge honor. I was very, very proud of that. So then came the question of which picture to pick for the cover. And I picked this one because of another thing I'm proud of. And that is I really learned how to be a patient astrophotographer on this image. So because of the law of diminishing returns, doubling your exposure doesn't double your result. When I got to 30 hours on this object, I couldn't see the squid. So I thought to myself, do I want to go further? And there's no point going a little further. If you're going to get any better result, you got to go long. So I went from 30 hours up to 60 hours, and I could still barely see the squid. I'd been shooting it for about 3 months by this time, and nothing else, just shooting this every night, every clear night. And I got to 60 hours and I could still not see the squid. And so I ended up going to 104 hours on this object. That's what you see here. And so I'm proud of being patient enough to not shoot anything else for all those months and tease out that beautiful squid. It's just a lovely object. And
Did you use different filters for it, or was this one open?
Yes. Well, I shot with red, green, and blue filters to get the natural star colors. And then I used a hydrogen alpha filter to get the red, the nice red of the emission nebula. And the squid was captured using an oxygen nebula, which emits in the green and the blue, and gives you, it lets through oxygen emissions, which are in green and blue, and that makes that nice teal sort of color. So putting it all together, you got this nice natural looking background. And there's another really cool nebula down here. There's so much going on in this picture.
I think you had another picture you posted recently that had like five background galaxies visible while the main one you were shooting was there in prominence.
There's let's have a look here. Just a minute. I'm gonna just have to share a different screen with you, I think. But let me just find, I think I know what you're talking about. It might be NGC 5746. This guy right here. Do you see this? Do you see this screen with a couple of galaxies on it?
With a few galaxies, yeah. It's
well, it should have one big edge-on spiral. No, okay, hold on a minute.
It's still showing the initial one that you had on.
Okay, so stop share screen, and go to photos. Okay, this might work better. There you go.
That's the one, yep.
Okay, so here's NGC 5746. And down here is NGC 5713, but you can see there's another galaxy down here. Here's kind of an interesting blue galaxy at the left. There's a little smudge there. There's galaxies everywhere in this image. Another recent cool image is, hang on one second. I've got this image of M97 and M108, which is recent. And again, I have to share that screen. Here we go. So this is, at bottom right is the Owl Nebula. And then at the upper left is M108 and SA108. But can you see, see the star in the center? Look at all the galaxies around that star. I don't know if I can zoom in anymore. Let's see.
Wow.
And look at all the galaxies up here.
How long of an exposure was this?
This is 31 hours and 21 minutes. And it's using kind of a cool technique. So when I was giving my presentation, I showed you a photograph of the two telescopes and the two cameras that I'm using right now.
Yep.
So this image, actually, all my recent images the last couple of months, I've been using the big telescope to capture luminance and or narrowband, hydrogen or oxygen. And I've been using the one-shot color camera on the small telescope to get the red, green, blue natural color. and then putting it all together. So I'm using high resolution luminance with low quality color and getting, bang, this amazing result. So I'm writing an article for Sky and Telescope about this right now. Two eyes are better than one.
So people are saying it's a feast for the eyes, and they're starting to run out of ways to describe how amazing this is to see. And I think I concur with them completely. This is fantastic, Ron. Thank you so much. Oh, wow.
Beautiful color contrast.
Thank you.
You
Thank
just
you.
labeled everything.
I don't know if you can see it well, but do you see the green shell, outer shell around there? And here's the annotated version that shows where some of the galaxies are.
And that's in width, that's less than an arc second in size, isn't it? No.
No.
This is 12 arc seconds or so. From
M108 is
108,
about 12 arc seconds.
Yeah.
This is NGC 4236. Again, lots of galaxies in the field. You saw that one. I'm working on, so I shot this in 2017 with the same one-shot color camera on telescope that you saw. This region here, where the blue nebulas are, I'm reshooting that in high resolution, and I'm just going to show you, I know I lost you there. I'm just going to show you what that's going to look like. This is a rough process on that same target. Zoom, share screen. Here it is in high resolution. So there's those blue eyes peering out of the dark. Amazing, eh?
That is.
Some people have asked why I get diffraction spikes on a refractor. Diffraction spikes are pretty common, or they're
reflectors.
They're not common. They're always present with a reflector, but they're uncommon with a refractor. But I think my pixels are so small on this camera that you're actually seeing diffraction spikes off the micro lenses on the sensor.
Oh. Can you give us an idea of the resolution that you're getting here in terms
of? Yeah, this is one arc second per pixel, and the moon is about 1,800 arc seconds wide. So the full moon would cover 1,800 pixels on my camera side to side.
Right, but you are getting 1 arc second per pixel in resolution.
No, I'm getting 1 arc second per pixel in camera resolution. My Sky gives me about 2.5 arc seconds per pixel.
Okay.
And I milk it.
Do you use any light pollution filters? And if so, what do you like to use?
I've occasionally used, and I am currently using a filter made by Optolong, which is called the L Pro filter. It's a light pollution suppression filter, and it lets through all of the wavelengths that I want to image, but it cuts out specific wavelengths of mercury and sodium lamps, like street lamps, that tend to cause light pollution. So it does impart a slight color cast to the image that has to be corrected in processing, but I don't find that objectionable. The other filter that I've used to deal with light pollution is particularly good for emission nebulas, and that's the Optolong L Enhance filter. And I'm about to test a new one for them called the L Extreme filter. Both of those let nothing through except for a few specific wavelengths of hydrogen and or oxygen. And I've used that filter to take some pretty nice narrow broadband images. Let me just show you one. Again, I know you've lost my screen. I have to navigate to that location. AstroPix, just a second here.
And by the way, those that haven't been to Ron's website, astrodoc.ca, it is so worth a visit. You'll lose a lot of time on it for checking it out, but there's a lot of amazing stuff on that website.
So here's, I'm going back to share and share that with you. There you go. So this image of the Heart and Soul Nebula, which can you guys see it?
Yeah.
Yeah. This was shot with a Takahashi 4-inch scope with a reducer corrector in it. So it's running at 387 millimeters. And it's using a QHY one-shot color camera with an L-enhanced filter that's only letting through the emissions of hydrogen and oxygen. And then I did some color tweaking to get the colors to look more natural. There are many other brands of light pollution suppression filters. I just haven't used them, so I can't comment on how good they are.
Ron, when you say the color's more natural, I mean, if we were able to go there and look at these, is that the colors they would appear to our eyes? Do you think?
Well, if you were able to go there and you were right in the middle of it, you'd see the blackness of space and some stars.
Right. But
because the gas is so tenuous. I've enhanced this dramatically in the vernacular, stretched it to make things that were hidden in the shadows visible.
Right. Okay.
But that said, if you looked at the relative wavelengths of light that are being emitted by the atoms in these objects,
yes,
they would have approximately the colors that I'm showing you here.
Excellent. That's nice to know. Beautiful.
So we've got one other question for you, and then I think we'll call it an end. We'll let you stop and catch your breath. But the question's actually a very interesting one because
I have to get out to the observatory. It's clear here, and I'm shooting H alpha all night.
So here's the question: how do you choose your targets? With so many amazing things to be able to look at and try to capture, how do you choose what you want to take a picture of?
I have a really good book that I want to show you. I like it so much that I actually bought 2 copies of it, so in case I ever lose one. It's called the Deep Sky Image Catalog, and it shows you month by month all the different objects and the scale that they are. I'm trying to find you a page with some objects. Right, so I go through, I peruse this month by month and find things that I haven't shot before. You know, a long time ago, I shot most of the big splashy objects. So now I'm always looking for what's nearby that I missed. If you go to my website and you look in the articles tab, I have a Sky and Telescope article on overlooked objects. And so I tend to cast around for the things that are near the showstoppers that maybe people don't shoot that often, that are underappreciated. But I also, you know, so that's one part of it. Another part of it is, practically speaking, so on a night like tonight, I have about 5.5 hours, 5 hours of astronomical darkness, maybe 4 hours. I'm going to try to pick a target that transits around 1 a.m. local time. And so that I get it on both sides of the meridian as high as it can possibly be. So I consider that sort of thing too. And then the third thing that's really important to think about is the image scale. You know, is it going to fit on your sensor, or is it going to be too tiny on your sensor? So you want to pick an object that matches what your telescope is producing. And one of the other things I think about is the phase of the moon.
Right.
So it's a full moon tonight. This would be a great night for shooting a globular cluster or an open cluster. Not a great night for shooting a faint nebula or a faint galaxy, except H alpha. If you're shooting far away from where the moon is in the sky like I am, I'm going to shoot H alpha on Messier 101 all night tonight. So that's a lovely spiral galaxy. And I want to get the H alpha knots in it. And the moon is nearly full. So I'm doing that all night tonight.
That's fantastic. Thank you so much, Ron, on behalf of everyone. It was an amazing presentation. It was relaxed. It was fun, to borrow the comments made on the chat by Janine. It was informative. It was just a great way to spend a Saturday night. Thank you so much. Lots of claps coming up on everybody's profiles, which is great. I'm going to invite anybody who wants a copy of the slides or who wants to know what the link is once we get this recording up on our and available to you. Please drop me an email. It's montrealrasc@gmail.com. And I invite anybody who wants to stay behind to chat. A few of us are staying on and just chatting about local, but we're going to let Ron get to his observatory. Thanks again, and I'll get you a coffee next time we meet up in Guelph.
That would be great. Clear skies, everybody. I hope you enjoyed the presentation.
That was great. Wonderful. Nice
Bye,
meeting
everybody.
you.
Good evening.
Nice.
Amazing.
Hey, and awesome to have the space station on the call. And David Levy. Thank you, David. You know, I'm a Montreal boy. I grew up in Montreal. And
we switched spots.
Yeah, we did. Now I'm in Guelph, you're in Montreal. But I grew up in Montreal, and everybody in Montreal knows David Levy. So awesome. Thank you. Thanks. Bye for now, guys.
Bye.
Bye, Ron.
Bye, thanks.
Nice to meet you all. Hope to see you again sometime.